Welcome to another deep dive. This time we're going to be exploring hydrogen production.
Ooh, very timely.
Yeah, definitely a hot topic, and we've got a bunch of U.S. Department of Energy documents to help us out today. And
Excellent.
yeah, it should be fun. So let's jump right in.
So good.
Okay, so what's the big deal with hydrogen? Why is everyone so interested in it these days?
Well, it's interesting because hydrogen, it's not like, it's not a fuel source in itself, right? It's an energy carrier.
Oh, okay. So it doesn't occur naturally like coal or oil or...
Yeah, you're not going to dig it up or anything like that.
Yeah.
It's more like, think of it like a battery. It
Yeah.
stores energy that's been produced somewhere else.
Oh, I see.
And that makes it super versatile, and it's
Yeah.
got a lot of people excited.
So then how do we get hydrogen if we're not mining it or drilling for it?
Right, so that's the key question right now. The main way hydrogen is produced in the U.S. is through a process called steam methane reforming.
Okay.
And basically it uses natural gas as a starting point.
So not exactly the cleanest method then.
Well, yeah, that's the catch. Right now it's the most cost effective, but it does rely on fossil fuels.
Right. So it kind of defeats the purpose a little bit if we're trying to transition to clean energy.
Yeah, exactly. So the Department of Energy, they're definitely aware of that, and they're working on a couple of different angles.
Okay.
So on the one hand, they're looking at ways to make that current process, that steam methane reforming cleaner, by adding something called carbon capture, utilization, and storage.
Oh, wow. A mouthful.
Yeah, CCUS for sure.
CCUS, got it. Okay.
Yeah.
So basically capturing those emissions and either using them or storing them so they don't end up in the atmosphere.
Exactly. So that's kind of like a short-term solution.
A Band-Aid?
Kind of, yeah, but then for the long term, they're really putting a lot of effort into developing cleaner production methods.
Okay. Like what, for example?
Well, one of the more promising ones is electrolysis.
Electrolysis. Now, I've heard that term before, but I'm not really sure what it means.
Yeah, it sounds pretty sci-fi, but basically it involves splitting water.
Splitting water.
Yeah, into hydrogen and oxygen.
Okay.
Using electricity.
So like zap water and you get hydrogen.
Yeah, pretty much.
Wow. That's incredible.
And the really cool thing is that you can use renewable energy sources to power that process.
Oh, okay. So like solar panels or wind turbines.
Exactly. So then you're creating truly emissions-free hydrogen.
Now that's what I'm talking about.
Yeah, it's got a lot of potential.
So is that kind of like the golden ticket then, electrolysis?
Well, the Department of Energy, they have this initiative called the Hydrogen Shot.
Okay, I've heard of that.
And it aims to bring the cost of clean hydrogen down to $1 per kilogram by 2031.
$1, that seems pretty ambitious.
Yeah, it's a big goal, an 80% reduction from current costs.
Wow. And why is that dollar per kilogram figure so important?
Well, think about it. If we can get hydrogen that cheap, it becomes competitive with fossil fuels in a whole bunch of industries.
Yeah, that makes sense.
Like transportation, heavy manufacturing, all sorts of things.
So it could really unlock a whole new clean energy economy.
Exactly. And the fact that they're focusing so much on electrolysis and the hydrogen shot suggests that they see it as a key part of getting there.
So they're not just throwing money at the problem. They're really trying to target specific solutions.
Yeah. And they're not just funding research either. They've got some pretty specific technical targets for different types of electrolyzers.
Oh, really? Like what kind of things are they looking at?
Well, they're trying to improve the efficiency and durability, make them last longer, basically make them better all around.
So it sounds like they're really serious about this.
Yeah, definitely pushing this technology forward.
Now, I was also intrigued by this direct solar water splitting thing.
Oh,
Is that what it sounds like artificial photosynthesis or something?
yeah, that's a good way to think about it.
Wow, that's mind-blowing.
Yeah, so basically scientists are exploring ways to use sunlight directly to split water molecules just like plants do.
So no need for electricity at all, just sunlight and water, and boom, you get hydrogen.
Exactly. It's
Yes.
a pretty elegant solution if we can get it to work.
And how exactly does that work?
Well, there are a couple of different approaches they're looking at. One is called photoelectrochemical water splitting,
Okay.
and that uses special semiconductor materials to absorb sunlight and kind of kickstart that water splitting reaction.
Very technical.
Yeah. And then the other approach is photobiological,
Okay.
and that uses photosynthetic microorganisms like algae to produce hydrogen.
So we're talking like tiny little factories churning out hydrogen.
Yeah, pretty much.
That's wild.
Yeah, it's pretty amazing the things they're coming up with.
So do you think we could see this happening on a large scale anytime soon, this direct solar water splitting?
Well, it's still early days. There are definitely some technical challenges to overcome.
Like what?
Well, mainly efficiency and cost. Right now, it's not as efficient as some other methods, and it's still pretty expensive.
Right, so it's a long shot, but with a potentially huge payoff.
Exactly. If they can crack the code, it could be revolutionary.
It's amazing how many different approaches there are to producing hydrogen. It's like everything from mimicking nature to harnessing the power of tiny organisms.
And there's even more out there.
Oh, really?
Yeah, there's another area of research called microbial biomass conversion.
Wait, are you telling me that bacteria can produce hydrogen?
Yeah, it's true. Certain types of bacteria and algae can actually produce hydrogen as part of their metabolic processes.
That's incredible.
Yeah, it's a relatively new area of research, but it just goes to show how much ingenuity is being applied to this challenge.
Wow. It sounds like the possibilities are endless.
Yeah, it's a really exciting time to be following this field.
But I gotta say, with so many different options on the table, it's hard to know which ones are going to be the winners in the long run.
Yeah, it's like trying to predict the winner of a clean energy horse race.
Uh-huh. Exactly.
You've got some front runners like electrolysis that have a head start, but then you've got these dark horses like direct solar water splitting that could come out of nowhere.
And let's not forget those underdog contenders like the bacteria.
Yeah. The microbial biomass conversion folks, they could shake things up too.
It's anyone's game at this point.
Absolutely. The race is on.
It really is a hydrogen Hunger Games out there. So
Yeah.
what makes you think that those dark horses actually have a chance, like direct solar water splitting, for example? It sounds amazing, but can it actually compete with the more established technologies?
That's the big question, right? And I think the beauty of direct solar water splitting is its simplicity. If we can just figure out how to use sunlight and water to make hydrogen,
Right.
we don't need all these complicated machines or have to rely on the electrical grid. It's clean, it's efficient, and potentially super cost effective, once the technology catches up.
So it's all about overcoming those technical hurdles. What are the biggest ones right now?
Yeah, so the main challenges are efficiency and cost, the materials they use in these systems.
Okay.
They need to be better at absorbing sunlight and, making that water splitting reaction happen more efficiently. Plus, they got to be durable. They need to be able to last a long time out in the elements.
Yeah, of course, exposed to the sun and rain and all that.
Exactly. And then, of course, there's the cost factor. We need to bring the production costs down.
Right. Make it affordable.
Exactly, if we want it to be adopted on a large scale.
So it's a long shot,
Mhm.
but with a potentially huge payoff. What about that microbial biomass conversion?
Oh, yeah, the bacteria.
Yeah, can we really control these little guys to produce hydrogen on demand?
Well, that's the fun part, right? It's like taming the wild west of microbes.
I like that.
Scientists are trying all sorts of things to optimize these microbial factories. Some are genetically engineering them to be more efficient.
Oh, yeah.
Others are trying to create the perfect environment for them to thrive and pump out that hydrogen.
So instead of these giant industrial plants, we could have these bioreactors just humming along, turning organic matter into hydrogen.
Yeah, exactly. It's a
No.
pretty cool concept.
Sounds almost too good to be true.
Mhm.
Are there any other potential benefits besides just producing hydrogen?
Well, think about this. What if we could use waste streams as feedstock? Things like agricultural residues, food waste, even sewage.
Oh, wow.
We could turn what we consider garbage into a valuable resource.
Killing two birds with one stone.
Exactly, addressing waste management and energy production at the same time, it's a win-win.
Yeah, that's incredible. So even if these dark horses pull ahead, we still need a way to get that hydrogen to where it needs to go, right? We can't just have it sitting around in bioreactors.
Absolutely. You're hitting on a really critical point, which is infrastructure.
Right.
Even with the best production methods in the world, we need a way to store, transport, and distribute hydrogen efficiently and safely.
Right, so are we talking pipelines, special trucks, all new infrastructure?
Well, the good news is we don't necessarily have to start from scratch.
Okay.
We can actually repurpose a lot of the existing natural gas infrastructure.
Oh, interesting.
Yeah, like pipelines, for example. They can be adapted to transport hydrogen, and we can leverage existing technologies for storage and distribution.
So it's more about upgrading what we already have than building something entirely new.
Exactly, which makes it a lot more feasible and probably more cost-effective, too.
Right, that makes sense. But we got to make sure we do it right, minimize the environmental impact and make sure that everyone benefits.
Absolutely. Safety, sustainability, and equity have to be top priorities as we build out this hydrogen infrastructure.
Well, this deep dive has definitely been eye-opening. It's clear that there's no magic bullet, but it's exciting to see So much innovation happening in this field.
I agree. There's a lot of potential here, and I'm really encouraged by the Department of Energy's approach,
Hmm.
They're not putting all their eggs in one basket. They're investing in a whole range of technologies.
Yeah, hedging their bets.
Exactly. And that gives me a lot of hope for the future of clean energy.
It's like being a venture capitalist for the clean energy revolution.
Ha ha. I like that analogy.
You're investing in all these promising startups. Some will succeed, some will fail, but you're pushing the boundaries of innovation.
Yes, exactly, and driving progress towards a more sustainable future.
Now, speaking of investments, what about public awareness?
Oh, that's crucial.
Yeah. It's not just about scientists and engineers making breakthroughs, right?
Yeah.
Everyone needs to understand what's at stake.
Absolutely. Public support is essential for driving this clean energy transition forward. People need to know about the benefits of hydrogen,
Yeah.
not just for the environment, but for the economy and energy security as well.
So what can our listeners do to get involved besides listening to this podcast, of course?
Well, I always recommend checking out the Department of Energy's website. They have a ton of information.
Oh, yeah, lots of good resources there.
Reports, fact sheets, even interactive tools where you can explore different hydrogen production pathways and see how much they cost.
That's really cool. And if you really want to make a difference, reach out to your elected officials.
Yes.
Let them know that you support clean energy policies and investments in hydrogen infrastructure.
Every voice matters.
It does. So it's not just about learning about hydrogen, it's about becoming an advocate for it.
Yeah. Exactly. Be a champion for clean energy.
Well said. So out of all these different pathways and potential solutions, is there one that you're personally most excited about?
Oh, that's a tough one. It's like asking me to choose my favorite child.
Fair enough.
But I will say there's one approach that I think has the potential to be truly transformative, and that's...
I'm on spill the beans. Which one is it?
Well, it's not so much a single method, it's more of a hybrid approach.
Okay, a hybrid. So like combining different methods?
Yeah, exactly. Instead of just focusing on one, we could leverage the strengths of several.
So like a system that could switch between different methods depending on what's available.
Exactly. Like imagine a system that uses electrolysis powered by renewables when the sun is shining or the wind is blowing.
Okay.
And then it switches to biomass gasification when those resources aren't available.
And we could even throw in some natural gas reforming with carbon capture as a backup.
Exactly. Just to make sure there's always a steady supply of clean hydrogen.
So it's like a clean energy orchestra, with each instrument playing its part at the right time.
Haha. I love that analogy. It's all about creating a harmonious whole.
But that sounds incredibly complex. Is it even realistic?
It's definitely a challenge, but I think it's doable.
Yeah.
We already have the technology for each of these production methods.
Right.
The key is to develop a smart system that can integrate them all seamlessly and adapt to changing conditions.
So it's not just about the individual technologies, it's about the brains behind the operation.
Exactly. We need a smart grid that can orchestrate this whole clean energy symphony.
And with all the advancements in AI and machine learning, I think we're getting closer to that.
Oh, absolutely.
This whole deep dive has really been eye-opening. It's not just about replacing dirty fuels with clean ones. It's about rethinking our entire energy system.
Yeah, it's a whole paradigm shift.
Exactly. And it requires us to think outside the box to embrace innovation and challenge the status quo.
Couldn't agree more.
Well, I'm definitely feeling more optimistic about the future of clean energy now.
Yeah, me too. There's a real sense of momentum building around hydrogen, and I think it has the potential to make a real difference in the fight against climate change.
But we can't forget about the human element.
Oh, absolutely.
The success of this transition ultimately depends on us. Informed citizens, engaged communities, and policymakers who are willing to champion these clean energy solutions.
It's up to all of us to make this happen.
So this deep dive into hydrogen production has been more than just an exploration. It's a call to action.
I like that, a call to action.
It's an invitation to become part of the solution.
And it starts with staying informed, asking questions and having those important conversations about the future we want to create.
Well said. So to our listeners out there, we encourage you to continue exploring this topic.
Yeah, there's so much more to learn.
There's a ton of information available online from the Department of Energy website to countless articles and videos.
Dive deep, challenge your assumptions, and imagine a world powered by clean, sustainable energy.
Because together we can make it happen. Thanks for joining us on this deep dive into hydrogen production. We hope you found it as fascinating as we did.
It's been a pleasure.
Until next time, stay curious and stay engaged.